All right, so today we're going to talk about Lesson 5, proportional and non-proportional relationships. So for something to be proportional, all the unit rates must be equal. So what we are looking at here is we would do 60 divided by 1 to figure out one unit rate. That's already at a unit rate because the denominator is 1. The next one we would be looking at is 120 divided by 2. And in order to simplify this to get to a unit rate, I'd have to divide both 120 and 2 by 2, and I would get 60 over 1. So far, these two unit rates are the same. In this case here, I'd have to do 180 divided by 3. And of course, I'd have to divide by 3 to both 180 and 3 in order to get to 60 over 1. So because all of my unit rates are the same, it is proportional. If something is non-proportional, all unit rates are not equal. Once you find one unit rate that isn't the same as the others, you are done. You can stop because it is not proportional then. Same thing here. I would do 60 over 1. That is already a unit rate. 120 divided by 2. I have to divide both numerator and denominator by 2. Now I'd still get 60 over 1. Again, so far, we're okay. This last one here, 185 over 3. I'd have to divide both numerator and denominator by 3. And in this case, I would not get 60 over 1. In fact, I would get 62.3 repeating over 1. Those unit rates are not equal, which means that it is not proportional. So let's look at example 1 here. Example 1 talks about, is this set of data proportional? And I want to find my unit rates. So first of all, I have 2 divided by 1. That's already a unit rate, so that one is good to go. This next one, 3 divided by 2. 3 divided by 2, in order to get it to be a unit rate, I have to divide by 2. And in that case, I would get 1.5 over 1. These are not the same. So we would say non-proportional because unit rates are not, that is the key word here, not equal. So because those unit rates are not the same, this is a non-proportional relationship. It is still linear, but linear and proportional are two different things. Example 2 here. Let's talk about how distance and time relate and see if this is proportional or not. So the first one is 24 over 1, already a unit rate, so that's good to go. 48 divided by 2. To get this to be a unit rate, I have to divide by 2. 48 divided by 2 is 24. 2 divided by 2 is 1. So far, both unit rates are the same. This next set is 72 over 3. Divide both the top and bottom by 3. 72 divided by 3 is 24. 3 divided by 3 is 1. Still the same. Things are looking very good here. This last one is 96 over 4. I have to divide both numerator and denominator by 4. 96 divided by 4 is 24. 4 divided by 4 is 1. All of those unit rates are the same. This, and that. All those unit rates are the same. So we would say that this is proportional because all unit rates are equal. Notice how the only difference between this explanation and the one on the previous page is the word not. If it is non-proportional, they are not equal. If they are proportional, they are equal. So let's talk about using these relationships now. So I have an equation here. It's y equals kx. Y, this is going to be important later, but y is my output. We can also call it our dependent variable. X is my input. It's also my independent variable. Again, those are going to be important later. The last letter that we're talking about here, the last variable, is called the constant of proportionality. It's the constant of proportionality. And the way that we find that is we take our output and we divide by our input. We take our output and divide by our input. So example 3, it says Nina charges $34.50 for 6 days of pet sitting. Find the constant of proportionality and then write an equation. What would the cost be for $4? $34.50 is my output. It depends on how many days I worked, and that's my input. So in order for me to figure this out, I would start substituting these numbers in where the variables say they should go. So my output is y. So I'm going to substitute y for $34.50 equals 6 is my input. So I'm going to substitute that right here, and k is the only thing that I'm looking for, which makes sense that this came out because it said to find that. In order to find k, I want to get k all by itself. So this is k times 6. So to do the opposite of that, to get rid of it, so the opposite of times 6 is divide by 6. And if I do $34.50 divided by 6, that'll tell me how much it make per day. And that value is $5.75. The next step, then write an equation. So now I know that k is $5.75. So I'm going to write my equation as y equals 5.75 k. Not k, x. $5.75x. The last thing it says is what would the cost be for 4 days? Again, 4 is going to be my new input. So I'm going to say y equals 5.75 times 4. And if I do 5.75 times 4, Nina will earn $23. Now, this is a word problem, which means I need to answer this in a complete sentence. So I would say Nina will earn $23 for babysitting 4 days. Again, make sure that when you are going through this, you are writing an equation. That is being found by using your k value. This is your constant of proportionality. Later, we're going to see that this is also named other things. It's also named other things. But right now, it is the constant of proportionality. Regardless, though, you always want to be finding this by dividing your output by your input. Output is going to go on the numerator. Input is going to go on the denominator. If anybody has any questions, please let me know. Otherwise, this is the end of Lesson 6. Lesson 5.